Hi everyone, my name is Chaolong Yang. I'm from National Taiwan University of Science and Technology. I am the Associate Professor of the Department in Industrial Management. Today, I want to present the top research topic as a predictive maintenance model based on fusion of time series and supervised learning methods. Here is the research background. Basically, as we know, the time series data from the multiple sensors equipped on the machine have been collected. And monitoring the machine health is very important for maintenance. So more and more research have been focused on developing a prediction model for predicting maintenance. It also means we have to know what's going to happen for the machine in terms of machine health. Then we are able to uh, perform the maintenance based on the understanding of the machine health. So this research's objective is very obvious. We want to develop a fusion model to combine two different machine learning methods. One is a time series analysis model, and second is a classification model to predict the machine status based on the collect sensor data. So here, since we need to use the fusion model, so in this research, you consider using multiple different models. For example, as what just mentioned, we first focus on the time series prediction model. Basically, we are thinking to use a naive Bayesian network. For classification method, as we know, it have been widely used in machine learning area or data mining area. And in this research, you consider using compare multiple different classification model. That would be random forest method and SG boost method and adaptive boosting method, and also the naive Bayesian network have been also used. And since we need to combine two different methods to using fusion model, so the fusion model actually we consider using support vector machine. So in this research world, we're quite focused on studying a particular historical researches have been published in the paper since 2015. And it's all related to the monitoring system by using certain machine learning method or time system classification model to study the to identify the value of sensors and use those that have been equipped on the particular machine. And those research work have been showing very interesting result that has several researchers have been developed different feature selection method or the classification model, and they also use the time domain or frequency domain features to to identify the particular signal sensors, so characteristic to understand machine health. So basically, this research work is found a similar uh, work have been done in literature, and we consider to use to combine multiple method to predict the machine health. So basically, we kind of follow the same way the people research have been published in the in the literature is about the monitoring hydraulic system, and that is a particularly open data have been quite used for the predictive maintenance research. As what we're just showing here is one of kind of continual research work by the Hellweight Pinelli that have been published in 2015. So basically, what they are trying to focus on that is a particular hydraulic system. In that hydraulic system, there are multiple different equivalent devices have been equipped. on the system, and the multiple sensor have been installed on a hydraulic system for how for them to monitoring for example, hydraulic accumulators status, or maybe the valves conditions. So in this research work, in order to evaluate our concept, that we kind of follow the exactly same previous research work have been published in literature, and we use the same data to analyze the data and try to compare results. Based on the previous research work, in this research, we focus on predicted the facility health. And as I just mentioned in literature, and there are two main facility health have been defined. One is the valve the conditions, and you have a different stage. For example, complete failures, a serious delay, slight delay, perfect condition. And another of our facility health focus is the hydraulic accumulator. That is a particular of a device, and he also similarly he also have a complete failures, a serious pressure loss, a slight pressure loss, a perfect pressure, and those are really our try to predict the status. And in this research work, we define this predicted target as a Y. So our research assumptions here. Now, first of all, the health condition of a machine can be obtained by sensor data. That's a very fundamental research assumption. And time series data of a machine health condition have trend and season effect, that which can be detected by the time series data method. And the health data contains the class of health condition, and that was just mentioned in previous slides. We have a very different condition, for example, complete perfect, or maybe complete failures, and a series or slightly condition we have defined. So the proposed fusion model basically have a two part, but no matter which part, basically we will start from the raw data, and we use the raw data to do feature extraction and feature selection, and we try to develop the prediction maintenance fusion model, and then we validate the result. And the fusion part is here. So basically, one part is focused on the study the sensor data we call X, and we use a supervised learning method, for example, XGBoost, to use the X to predict Y. So our predicted value is Y prime. That's for the very typical classification method. And another part is we focus on the time series analysis model. That what we will use, we will use the Y data. That was because what we just mentioned is a health condition, and use a time series model. For example, we use a non-invasive network to study using Y to predict the future Y. Then we get a Y prime, Y double prime. So since we have a two prediction model, one is a classification model, another one is a time series analysis model. So then we combine using that result by using the supervised machine, and that is what we call the fusion model, to use the Y prime and Y double prime and help us to predict the Y triple prime. The Y triple prime is the final predicted value. Then we hope in the Y triple prime the result is more accurate than when we want to predict the health condition. So we do have some data preprocessing only for the time series data. So basically we use the time series data decomposition method, trying to, for example, there's a valve condition and the hydraulic accumulators data. So we try to resolve the different residual and seasonal effect, trend effect, and so here is obviously the observation from original data. Then we try to decompose it to a different time series pattern. And we can use this pattern to predict the model. And that can be used for the non-invasive network. Okay, here's the data preparation for experiment. So basically, as you can see, we have a fusion model. For this classification part, we want to use the X data essentially to predict Y, and that part is for the training data set. Then we create a classification model, supervised learning method, and then we have a 30% of a testing data set that we can predict the Y prompt. Another part is we're using only Y to predict the Y double prompt. That would be only focus on time series data. And so that is similarly, we have 70% training set and we're testing 30%, and that's produce the Y double prompt. Then combine the Y prompt and double prompt, we use a support vector machine to help us to predict a real ground truth Y. This is ground truth Y. And that is also we need a model for training to train the support vector machine. Then we evaluate the final part is the predicted triple prompt with a ground truth Y. So here is the result. Basically, for while condition that we have defined in previous slide, we compare the fusion model and single model. For both models, we follow the executive standard supervised feature selection and unsupervised feature selection. And each one we supervisor we use Benjamin utility method, and we also use PCA for unsupervised method. And we compared 4 different classification methods since our time series data are using only the non-yield Bayesian. So classification model is for random forest, attribute, additive boosting, and yield Bayesian. So obviously, when we see this fusion versus a single model, we see the fusion model actually provide better accuracy, as you can see here. That's very obvious improvement. Similarly, for the hydraulic accumulator, we focus on the status and follow exactly the same framework. As we can see that our fusion model even they provide very close to perfect accuracy if you compare with single model. If you want to compare the percentage of data volumes, we can actually see that means that if you don't use 100% of data, we only 40%, 50%, 60%, so on, then we see our accuracy actually not so good, but 100% is using all data. But as you can see that even we have a relatively limited data set, then our fusion model still choose almost the best one. Following the fusion model, and can help us to adapt the data fusion and make sure that our prediction method can compensate the dropout of either classification model or time series model. Here's the conclusion. So basically, in this research, I'll propose the fusion model consists of time series model and supervised classification, and combine their result and use another supervised learning SVM model and support vector machine model to help us to predict the machine's health condition. And the results show that combine these two methods actually is able to improve the prediction accuracy. And those fusion model is also suitable for the analyzing collected cyclic data because that way is even better for the time series data. Okay. Thank you for your listening. Feel free to ask a question. Thank you.